All right, so my name's John Squire, and I'm here to actually talk to you guys today about security in consumer devices. My talk is called $30, 30 minutes, 30 networks, and this really did cost me about $30 and took 30 minutes to do a prototype. So, a little bit of an agenda. I'm going to give you the standard disclaimer, um, talk about what the project's actually meant to do, a little bit about the hardware, obviously give you a demo because it's pointless to talk about this if we can't do anything with it, explain why it works, and kind of where I want to go with a lot of my future research. So here's a disclaimer. It's my research, not my company's. If you break something, it's your own fault. Um, and if you want to contribute, I'm always looking for people to help me. So what's a cowbird? Cowbird is basically a brood parasite in nature, and what it does is it lays its eggs in other birds' nests to get them to raise its young. This is very beneficial for it because it obviously doesn't have to get resources. Um, it also ends up killing the birds either through starvation or ultimately pushing them out of the nest. Um, so it's kind of a friendly little creature. Um, So why am I calling this project Cowbird? A couple of years ago, I started a research project to map different security attack and defense techniques to predators that live in an ecology. Um, what you find is as you look at techniques, the uber worms or viruses, rootkits, the best ones actually have very simple behavior patterns, kind of like creatures in an actual ecology. Um, and if you look at even what's happened with worms in the past couple of years, one worm sits there and tries to compromise the next worm, patch its holes, and move up on the food chain. So Project Cowbird is one of the creatures of this larger research paper. Um, I'd actually stopped the research paper for a while because I was theorizing that for relatively little money, you could create, at a minimum, a nuisance attack. Think mice in a grain elevator, eating everything there. It's a very hard problem to control once they grab a hold. My problem was I couldn't build the devices I wanted at a cost that made it worthwhile. This kind of changed the other day when I was in my local computer store. So Project Cowbird, I basically took an off-the-shelf wireless media adapter, and the vendor in this presentation is not the only one to behave this way, so I'm by no means picking on them. I repurposed it for my own needs. So for this proof of concept, we run Kismet server and client on a device. Let me see. So there's the hardware, and this is where it gets scary. Technology is progressing so quickly that what would have been, a $3,000 computer 5 years ago, probably more like 8 years ago, we're getting everything we need to launch very sophisticated attacks with commodity hardware. These things go on sale because people don't know what they are. So that's where it came $30. Wireless card, which I can remove and replace the drivers. JTAG, so I can reflash it, which is actually being worked on. TV out, which is just uber cool. Unfortunately, all I'm giving you guys is a splash screen today. Infrared remote control, which makes giving presentations fun. And there's at the end of the talk, we actually did a little bit more hardware hacking on it yesterday. So why this device versus a Linksys WRT54G is actually one of the questions I've gotten already. So it's slightly less integrated, and it's also 20 bucks cheaper. It already uses the network to boot, like, again, a lot of these media devices do. It uses UPnP to boot, so it's more than happy to tell you its status is coming up. Basically what happens is the device turns on and says, hey, I'm over here, is there anybody who can boot me? And you say, I'll boot you, connect over here, and you feed it, it comes up running your software. Once it's up, it says, hey, I'm started, so you can go back and connect. And of course, the source code was available. That actually didn't end up helping me that much because the vendor decided it would be a good idea to zip a Unix tree. So lots of bus dissymlinks. So it's enough background. Let's actually show you what's going on here. So I've basically got, because I'm booting off the network right now, I've got a little VMware session set up to emulate typical network environment that would run one of these. I am not running, this is a Linksys device obviously, I'm not running Linksys as software just because it makes it a little bit quicker to do the presentation. Everything I'm doing here you can actually do with this stock Linksys software, and we'll talk about how this works after I run through and show it to you. Wait for my slow computer to catch up with me. All right, so on this screen, which I'll be flipping back and forth to, and hopefully it actually displays, which would be this is basically a TV tuner card. So we're going to start a Cowbird boot server, and we're going to feed the device my image. So power on the device. Top's just going to show you DHCP occurring. Bottom is going to show you the boot server feeding it an image and kind of the messages that come through as it goes. All right, so we've successfully started one of these devices, and as you can see on the TV out, all right, I'm running my software instead of Linksys' software. So going one step further, who cares? It's a wireless media device. I'm putting Kismet on a $30 device that's running in your house. So we're going to go ahead and we're going to connect to the device. Should be the first one. Yes, I know it's Telnet. The new version has a copy of Drop Bear in it. This is for demonstration purposes only. So give it a couple seconds and we'll see what clients appear on the network. And again, I don't even have wireless antennas on here now, so it takes a second or two to find devices. This is all running on a $30 device. From an attacker's perspective, this is kind of dangerous. I can throw this away. We'll talk in a second about some of the research that I'm doing in the future. This boots off the network and makes it blatantly obvious. It's meant to be a proof of concept. You don't have to be obvious about what's going on. I have a Kismet drone running at home, still running the original Linksys software. It's a couple of bugs still. It's an old version of Kismet. So going back to the presentation. All right, so why does this actually work? And this is really the point of this. To say this is a hack would be probably a stretch. There's no buffer overflows. There's nothing creative. The boot protocol for this device is really, hey, I'm awake. Okay, I can serve you. Connect to this socket. And over the raw socket, they send a CramFS image. But they call it image because that's confusing to users. Just using file will tell you that this is CramFS. Obviously, CramFS, standard Unix tools, you can build an image. It's an X-scale processor in the device. Half of the binaries on here are actually from Familiar, which is IPAC Linux, because I was lazy and I did this quick. There's no verification whatsoever of what's going on here, which is actually very typical of a lot of consumer devices. And it gets scarier because a lot of current VoIP phones that boot off of your network do the same thing. This is an entire class of device. all of these devices seem to put a lot of trust in the network. They're assuming it's your photos, it's your music, it's your network, it must be safe. So they have no qualms about putting their boot images on there. Most of them run on Windows. So think about spyware dropping Trojan software for whatever the most common media extender of the month is, and replacing what's going on. You can do this with the standard Linksys software. It's an XML file. All it has is file size. Give it the image, you can send whatever you want. So this is why it's bad. There's 2 of these in my lunchbox with a switch and all of the appropriate power supplies. And yes, this did make it through airport security, which even surprised me. I did look at it for about 4 minutes. So again, I'm being obvious about what's going on here. Not everybody else is as nice as I am. You know, I've got about 6 other random wireless media adapters or wired ones that I picked up in the store just looking for something. And the funny thing is, this was not my original intent. I was actually looking to do a home automation project and receive infrared and then block codes from going from room to room. I opened it being a security professional, and I said, I could do something much cooler with what's here. And the hardware really is cheap enough to throw away and requires no physical access. And you're seeing this more, not less. Lots of devices are trying to come to market quick. Most of them are based on reference designs. Going through the source code, you know, it was very easy to actually find the reference platform, find out how their bootloader worked, which is horrible, but it works. And then work forward. In a little more detail, what actually goes on is Linux actually boots on the device. The device then runs a user space tool to do its UPnP request. You send the image, it mounts it to temp space as a loop mount and runs a script. In their case, it's a binary. In my case, I just replace it with a script, kill off the processes I don't want, and then run whatever I want. Obviously, you can run NFS. You can do something much more stealthy. SSH reverse tunneling is kind of fun. Wireless bridging does work. So what can you do? And none of these ultimately solve the problem, but for a consumer device, most of them are good enough. Sign the image. Like, look at the security process of a TiVo, another common consumer device these days. They have signed kernels, and the system will not boot if you try to tamper with it unless you then go in and reflash the firmware. Right? That stops a trivial case attack like this. Authenticate the devices to the network server. Again, even if it does boot the image, most of these things play MP3s, photos. A lot of them are based on really old kernels and even older libraries. So you can do the classic JPEG overflow on whatever image library they're using for rendering. Create a private media network. It's actually what I do at home because I don't feel like looking at every device and I just want to listen to my music. Separate switch, put all the devices on it, sneaker net a drive to it, put it in, done. Or better yet, tell vendors you want secure devices. If my mom can't run it secure, it shouldn't be running, and my mom doesn't know it's not secure. And since the general populace obviously does not know, what these devices do, they just want to show, their family vacation photos to all their friends. It's not beneficial to vendors right now to actually build secure devices until something bad does happen. So where am I going with this? This is really a proof of concept, but it actually gives me a hardware platform to continue the ecology of security research. Some of these are actually on there.